Moving on to the next presentation. So now we have some inputs from the equipment maker, which is Leadmicro, who is currently a market leader in supplying of the deposition and thermal equipment solutions for TOPCon. We have Boachen LIAO, who is chief scientist at Leadmicro. He's going to talk about the equipment solutions for mass production of TOPCon cells. Boachen, the floor is yours.
Hi, can you hear me?
Yes.
Finally I make it. Finally I make it.
I'm also glad.
Yeah, thank you. And first of all, also thanks for the invitation. Yeah, give me this opportunity to share our progress. Yeah, sorry, let me share the screen first. Can you see the screen?
Yes.
Okay. Then I will start. Good morning to everyone. Yeah, very glad to have this opportunity to share with you the equipment solution for mass production TOPCon solar cells. Yeah, here is the content for today. I will give a briefly introduction about our company and the technology background, and follow with the equipment solutions for mass production of the PE-TOPCon 2.0 solar cells. Then followed by the 3.0 outlook, and end with a conclusion. Simple introduction about Leadmicro. Yeah, we are a global equipment manufacturer specialized in development, design, manufacturing, service of the advanced thin film depositions. We started with the ALD depositions, after that with the CVD and the thermal vacuum systems. And our service area mainly is semiconductor, photovoltaic, new energy, flexible electronics. Here is some milestone for our ALD and the PECVD deposition systems. We started with the ALD from 2016 to 2018. Actually, we introduced the world's first batch type of ALD with the highest throughput for the PERC cell to replace the inline type of system. In 2019, we started our journey with the PECVD and the PEALD integrated system and started our research on the TOPCon solar cells. Then after 2 years research in 2021, then we have several breakthroughs in the areas, including the PE-TOPCon new technology. We complete the pilot line research with the average efficiency of 24.65. Another thing is we also have an efficiency breakthrough for the tube type of ALD. So now you see it's a standard process for the high efficiency solar cells now. In 2022, we have several breakthroughs as well. We have the introduced new generation of tube ALD, new generation of the PECVD integrated PEALD system. And for the PE-TOPCon technology, we complete the gigawatt scale mass production evaluations. For here, we mainly resolve the yield issues for production. And we also successfully deliver 2 gigawatt TOPCon 20 projects mass productions. With this background, so this year we have another big progress. As you wrote, a new generation, even higher throughput, the tube ALD systems. And we have 4th generation PECVD system. Come to here, we use the pure PECVD system for tandem oxide and poly because the cost is lower. And for this PE-TOPCon technology this year also come into the thousands of gigawatt scale mass production expansions. And with the last year 2 gigawatt TOPCon 20 project background, this year we receive about 15 gigawatt 20 project based on our PE-TOPCon 2.0 technologies, which we will introduce shortly. Here is quickly some market trend from the ITRPV. From here, we can see for the next 10 years, it will about the PERC and TOPCon. And among them, 50% will be the TOPCon solar cells. But I think this is the updated expansion information we have here. If you look at sorry about some Chinese character in these figures, but if you look at the TOPCon, the yellow color, so basically by next year, we have chances to reach more than 50% of the market share, which means we can achieve the target for the next 10 years just within next year. Here is the technology trends for the tandem oxide and poly. From the left graph, you can see both the tandem oxide and the poly will move to in-situ deposition or dopings. For the polysilicon depositions, they compare with the LPCVD and the PECVD, you can see But after 10 years later, PECVD probably will occupy about 60% of the market. But according to the statistics now, actually, if you look at the right side, the PE market, compared to the left side, the LP, so the PE market already has a market share close to 50%. So we also achieve the target for the next 10 years just within these years. So that's the reason you can see once the technology breakthrough, how fast is the manufacturing expansions happening. Yeah. So come to the Leadmicro solutions for these TOPCon technologies. We have identified 3 areas for us. One is the front side aluminum oxide. Basically, we introduce ALD and the PEALD 2 technologies versus traditional PECVD. For tunnel oxide, we identify PECVD and the PEALD 2 technologies versus traditional thermal oxide. And for polysilicon, we introduce PECVD versus a traditional LPCVD. So among these 5 technology, we all prove its feasibility at the gigawatt scale. But however, due to the cost issue at this moment, only the first 3 technology now is slowly become the mainstream for this TOPCon expansions. Here are the product series for the technologies just now we mentioned. The first one, KF, is based on the tube type of ALD. And the ZI is basically based on our PECVD and also can be integrated with the PEALD. XH is based on our thermal system, basically has the function of diffusion, annealing, oxidation, and the LPCVD, which we will talk them individually very soon. Here also share with you the progress for our PE-TOPCon technologies. We have this. In 2021 May, we complete the pilot line research. So mainly solve the issue is the process and equipment bottleneck of this technology, which we will share a little bit shortly later. Then after that, we move to the mass production evaluations. After resolve the pilot line efficiency issue, then we have to resolve the mass production yield issues. So for this period, we are mainly to resolve the yield issue. The yield is from less than 30%. Then we have improved about 97. So to prepare this technology ready for the even larger scale mass productions. Then with all this data in hand, then this technology come to another dozens gigawatt expansion, which is today. Yeah, in here, we mainly solve is even larger scale mass production expansion problems, like the facility, like many another issues. When you go to larger scale, first time, then you still have some issue have to resolve. From the efficiency wise, we also do some optimizations. So come to here, we have reached the efficiency about 25.5. By the way, there is a disclaimer. So for all these efficiencies from the manufacturing production line, they maybe depends on the reference cells everyone use. Then after that, come to the December, actually the efficiency already reached the 26. Basically with the TOPCon 2.0 technology. From here, there are 2 major changes for the second half of the year. First is the cost reduction. We have introduced the 8% frosting to replace the 2% one. So this one can reduce the cost dramatically. The efficiency wise, the major improvement is to adding the selected emitters. Yeah, this is the journey for this technology up to now. So with this in our mind, we understand the 1.0, 2.0. Then the first thing we want to introduce you is our PECVD technologies. Here is a comparison between the tunnel oxide and poly mesh production technology available. So from here, we're providing is the solution 4 and the solution 5. Basically, the only difference is the tunnel oxide difference. One use the PECVD silicon oxide, one use is PEALD silicon oxide. For polysilicon, both are used the PECVD in-situ dope poly. Yeah. So last year we have completed all 2 technology gigawatt scale mass production. Yeah, come to this year due to the cost competition of obviously the first solutions PECVD tunnel oxide plus the PECVD poly. Yeah, becoming dominating the market. And become the dozens of gigawatt expansion through this technology mainly is due to the cost issues. Yeah, so our tool, yeah, we have a patented technology where our tool is able to integrate both the PEALD and the PECVD technology into one tube. So I think we are the first one to have to achieve this one, prove this one in the production line. So with this in mind, so we can do the in-situ tunnel oxide, in-situ polysilicon doping, in-situ element doping, in-situ various thin film. So for example, the mask layer can be done easily. And with the in-situ doping, the doping level is also tunable. So with all these advantages, we have achieved the production line VOC average is greater than 725 millivolt. PECVD, the PECVD, we have discussed it many times. I will not go into details here. So now we have discussed many of the advantages of the PECVD. Definitely, why is it widely adopted in the market earlier? Definitely, it has its own needs. So we should spend some time to discuss its bottleneck. How we resolve. So after, so here we just list out two major bottlenecks we have to resolve along the way. One is the equipment bottleneck. So if you are familiar with this tube type of PECVD in the PERC time, you know, it's meaning to depositing the insulating films. Yeah, this is the first time we use this type of tube of PECVD to do the conducting films. So why this is critical is like, so use the graphite board as an example. You can look at the top image. The graphite board, when you we have two neighboring graphite plates. We have a ceramic insulators to prevent its conducting, because we are conducting AC. We are inputting the AC current inside. So if you are doing the depositing the insulating films, it's no problem. The ceramic will continue insulating. But if you are doing the conducting films, after more and more film thickness deposit, the ceramic insulator may become conductive, like the bottom graph, the silver color you may see. So in this way, the working principle doesn't work for this tube type of PECVD anymore. So basically today you see the two, although the outside still looks like the traditional PECVD, but however inside the tube, we have to do many of the things to prevent it from conductive. Yeah, so the inner part we have changed a lot, you know, make it works for this in-situ doping. Yeah, besides the equipment bottleneck, there is also a process bottleneck, which is well known in the community, which is blistering issues. So this is also a major challenge. So we have really explored all the major mechanisms in the literature and in the market. And finally, we have adopted the all three mechanisms. We have utilized the all three mechanisms in order to widen the process window for today's mass production. I will not go into the details here. If you are interested, we can discuss a little bit more in offline, because due to the time constraint. So after we break through all these equipment bottleneck and the process bottleneck, finally we have a breakthrough for this technology. So with all this achievement, also has been selected as the PIP magazine as a featured cover twice in this year. And it also has well recognized internationally for all this technology developed. After this, we would like to come to our second flagship product, is the thermal ALD system. Why come to this high efficiency cell? We need the thermal ALD system. For this image, is the background reasons. The main reason is still the 100% conformity for the ALD system. If you look at the left corner, bottom corner, the TM image, SEM image, you will see that unlike the PERC cell, which we passivate the real side, the poly surface, you come to the TOPCon cells, you need to passivate the front surface. We all know due to the light receiving side, we need to have the texture surface. So if you have to passivate the texture surface parameters, so the conformity become a challenge. So ALD has a disadvantage. So that's the main reason behind it's become a standard technology. Yeah, this is the version of a tool we introduced. It has a very, very high throughput. Almost one system you can match to 1 gigawatt production line. In 1 gigawatt production line, you just need one tool. So so each tube is working independently. It's very important, and this tool also very highly mature. Why it can quickly adopted by the market? Because it has been used since 2016 time. The major breakthroughs we have tailored process for the PERC XPC perovskite tandem. So the main breakthrough this time is the process breakthrough. We developed the process. But the equipment, the improvement is mainly on the capacity to further to reduce the cost. Why we have this breakthrough is because we also have a very strong foundation to prepare us for this TOPCon era. So actually from 2022, we have also resolved the bottleneck for ALD aluminum oxide from the lab to product cell commercialization. Mainly is the firing stability issue. Come to 2013, we already proved the ALD ALOX can provide excellent service passivation for boron surface. So that's the reason paved the way for today's TOPCon applications. Another thing also very important is the ALD aluminum oxide from the product time from the back side, you move to the front side, the light receiving side. So the film performance under the light soaking is very important. We also do a light soaking mechanism studies. And the first time we introduced a light trapping model into our solar field and explained this phenomenon, we have a light enhanced passivation. So if you notice that this for TOPCon, we also use is the light injection methods. So basically, all these things also prepare the fundamental understanding 10 years back. So to prepare us for the breakthrough today. So here is a detailed comparisons between 3 different technologies for TOPCon applications. The PECVD 2-in-1, the lack of the conformality, so the efficiency a little bit lower. So the competition between the batch type of ALD and the in-line type of ALD. Early type of ALD efficiency is about 0.2% lower than in-line type. Yeah, after we resolve this efficiency bottleneck, all the rest are the advantage, except a little bit of wraparound. Yeah. And come to the XPC applications. If you look at the graph left, you can see suddenly ALOX, you need the double side depositions. As we know, both the inline type of ALD and the PECVD 2-in-1 are all single side depositions. So that's the reason batch type of ALD dominating the market in this area. Yeah, this is a roughly overlook of our equipment layout from left to side, from the AGV to the reactor chambers. Lastly, we look at our thermal systems, which also are important part for our turnkey solutions, which has the boron diffusion, oxidation, and the annealing process. For these two, the main challenge is the vertical is the capacity. So only the capacity can reduce the cost. And another thing is our loading method. We have both 3 type of loading method: vertical, horizontal, and light PE. We also do a very carefully simulation for our temperature and the gas flow to ensure the performance of the tool. Yeah, nice. Similar, we also do the silicon carbide pedal simulations, make sure the reliability of the tool. The left side is how is the light PE loading methods looks like. Yeah, in this area, we also have some publications in 2021. At that time, we first introduced the boron chloride precursors, gas, and together with the horizontal loading methods. We have shown some of the issues there. Yeah, come to the last is our PE-TOPCon 2.0 solutions. Mainly is to adding a selective emitter. Yeah, so in just now mentioned in 2022, we have completed delivered 2 gigawatt TOPCon turnkey project. 1 gigawatt is PE-ALD silicon oxide plus the PECVD polysilicon with a wafer size of 182. Another gigawatt, 1 gigawatt is based on the PECVD silicon oxide plus the PECVD poly with a wafer size of 210. So with all this background behind, this year we have received about 15 gigawatt for PE-TOPCon 2.0. For this 15 gigawatt, all based on PECVD tunnel oxide PECVD silicon technology. And now we come to the outlook for the next. So above 26, what we can expect for the next year. So basically, we still can add in a lot of things. For example, bipoly, PVC. Example, yes.
Hey, Boachen, can you wrap up in a minute?
Sure. Yeah, well, and also a calculation. So to make it more detailed for cost reactions, as I mentioned, is for polysilicon thickness. Currently, we are at 110 to 130. It has we have also tried in our in-house, and the move to 60 nanometer is highly possible. It can greatly reduce the cost, and also if the thickness reduced to half, then your throughput may be double. Equipment will reduce its less. So this all can greatly reduce the signing usage. For the efficiency, just now we have mentioned about that. So now I come to the end of my conclusion. So we have today has share our PE-TOPCon 2.0 turnkey solution. The main is the deposition tools with our tube type of ALD and the PECVD tunnel oxide plus the PECVD poly, and also our thermal systems. And we end with a future outlook for our PE-TOPCon 3.0. That's all for my presentations. Thanks.
Thank you very much.
Thank you.
Actually, I have few questions, but unfortunately, we don't have time for that. So please stay tuned, and if there are any questions in the chat window, please try to answer.
Yeah, sure, no problem. I will handle that.
Okay.
Okay, thank you. Thank you.
So now we'll